So let's start to look at the final question that I gave you for functions revision. If you can do these 6 questions, if you can understand them, and if you think you could do similar questions to these, I would be happy that you understand the coursework for functions for maths. But there are definitely some tricky parts to this. So if there's any bit that you're still a bit hazy on at all, please do let me know and I can go over it in more detail with further examples in the book, in the exam papers, or even just making some up if you need another example of a similar kind of question. So this one here, another 25 mark question. So again, 12.5 minutes is the amount of time you'd have in an exam situation for this. We're shown the graph of a function f, and as you can see, this is a quadratic function, okay? You can see our curve shaped there, and this would be symmetrical if we continued it back here. The graph of another function g is a straight line, okay? And they've told us that g of -1 is -6. So what are they telling us there? They're telling us that when x is -1, y is -6. So they've told us a point that's on the line. -1, 6. And here we go, there's 6. So that point is on my line. And also the g of 3, -1, -6. I put that in the wrong place. Now, -1, -6, so we're down here. And 3, 6, so 3, and we're up as far as 6. And so we can draw in the line. They've asked us to draw the graph of g on the diagram there. So we can draw this in. You should use pencil for it. Go over it in pen if you want, or if you're feeling very confident, you can go straight for pen. Technically, they don't penalise you for using pen, but it's harder to remove any mistakes. So there we go. There's the graph of our function g of x. Now, use the graphs to find the 2 values of x for which g of x is equal to f of x. So what are they asking for there? The points of intersection. Points of intersection. So we've got the point here. It looks like -3. And we've got a point up here, which is a little bit more than 5. Say that looks like at about maybe 5.2. And probably about 13 there. So this point up here looks like maybe 5.2, 13. Again, we're estimating. And this point here, it's on the y-axis, so x is 0, 0, -3. So long as I've shown my work on the graph like this, I've satisfied this requirement, and I write down the values. Would I get full marks for just writing them on the graph like that? You probably should. The points of intersection, 0, -3, and 5.2, 13. Let's just check, have we answered the question that was asked? And we haven't. They've asked us not for the points of intersection, but for the 2 values of x. So when x is equal to 0, and when x is equal to approximately 5.2, if I've drawn my graph correctly. Now, it could have been 5, if my graph was tilted slightly, but we write down based on the graph that we have drawn, okay? And if it's close enough, you won't lose marks for a point or 2 in your decimal places. Now, the functions g and f are defined by these 2 here. So again, they have this notation g such that x is mapped onto. Let's just say that's g of x equals to ax plus b, or if you prefer, y equals ax plus b, and f of x is equal to x squared plus something times x plus something, or y equals x squared plus px plus q. Wrote it down wrong there. Now, the graph of f crosses the x-axis at -1 and 3 as shown, and it also clearly crosses the y-axis at -3. So we're going to find the values of a, b, p, and q. They want us to find the equations of g of x and f of x, and then they want us to solve them simultaneously to solve g of x equals f of x. So let's do that. So how do we use my roots? My roots are x equals minus 1 and x equals 3. And so my factors are x, we just change the sign, plus 1, x minus 3. And I multiply out those brackets to give me x squared plus 1x minus 3x minus 3. So this is my f of x. F of x is equal to x squared minus 2x minus 3. So that's how we get our quadratic function from the roots that were given. And so p is the x coefficient is equal to minus 2, and q is the constant is equal to minus 3. There's the information that we have. Okay, what about my line? Well, again, my line, I've got 2 points. And if I want to find the equation of a line, I need to find the slope. So I've got the point minus 1, minus 6, and 3, 6. So if I label those as x1, y1, x2, y2, I can find the slope of the line. Now I could do it by rise over run as well. You can see we've got 3 over 2 here, should be my slope. But, you know, just in case I've made any mistakes with my graph, I'm going to do it by formula. So the slope of the line is the difference between the y values divided by the difference between the x values. That's rise over run. 6 plus 6, 6 minus a minus 6, divided by 3 plus 1, 3 minus a minus 1. That's 12 over 4. Oh yes, of course, so the scale is different, so I can't just count the boxes as well. So it's much easier to do this by formula. And my slope is equal to 3. Then I'm going to fill in 2. Y minus y1 equals m by x minus x1. So I do much prefer finding equations of the line by formula and slope by formula than using the graph, especially with tricky graphs like this where the scale isn't the same on both the x-axis and the y-axis. It makes rise over run a little bit misleading. So I have y minus y1, y minus a minus 6 equals m by x minus x1, x minus a minus 1. Multiply out my brackets. Y plus 6 is equal to 3x plus 3. So y is equal to 3x, 3 minus 6 minus 3. Why did I write it like that? Because this is the format that we want it in. So we can say that g of x is equal to 3x minus 3, and a is equal to 3, and b is equal to minus 3. Now, have we answered everything? Not quite. We now need to do this final step here and solve g of x equals f of x. So let's take a look at that. I'm just going to do that on a separate sheet. So if g of x is equal to 3x minus 3, and f of x is equal to x squared minus 2x minus 3, then if I'm putting them equal to each other, solving g of x equal to f of x, or I'm writing it this way around and you'll see why in a second, I'm just saying that this part here is equal to this part here. So x squared minus 2x minus 3 is equal to 3x minus 3. Now, can I solve this? Of course I can. I just bring everything to one side. X squared minus 2x minus 3x, and a minus 3 minus 3, that becomes a plus 3. They're going to cancel. So I'll get x squared minus 5x, that's 0, equal to 0. Now how do I solve this? I can use the minus b formula with a equals 1, b equals minus 5, and c equals 0. Or take out a common factor. And the common factor is much quicker. So if I take out my common factor, I get x bracket x minus 5 equal to 0. So x is equal to 0 or x is equal to 5. Okay, compare that to my answers up here, and you can see because my graph was a little bit inaccurate, just even a tiny bit off, it should have crossed here. But, you know, we just have to draw it based on what we filled in ourselves, and when the scale is so small like this, even the tiniest tilt of angle can give you a slightly wrong answer. But I wouldn't lose marks for that. The graphs are inherently inaccurate compared to algebra, as we've seen across these questions. So in any case, x equals 0 or x equals 5. So they have asked me to use algebra to solve g of x equal to f of x. Have I finished? All I've done is find the x values. I do need to sub them back in to where? Either one of these. It doesn't matter. So when x is equal to 0, y is equal to 3 by 0 minus 3. So y is equal to minus 3. And that was the point 0 minus 3 on the y-axis of our graph. And when x is equal to 5, y is equal to 3 by 5 minus 3. So y is equal to 15 minus 3, which is 12. And so we have 5, 12 as our 2 points of intersection. Again, those are slightly different to what I wrote down from the graph. And which one is correct? What's the right answer? What I have from the graph or what I found by algebra? The answer is the algebra. The algebra is correct. My graph is a little bit inaccurate because I didn't draw my line straight enough, but I wouldn't lose marks for what I've done there. I've written down the answer based on what I can see on the graph. Okay, so hopefully that's clear enough for how you work with functions and their graphs. And I know it feels maybe a little bit fluffy, this inaccuracy with graphs and this idea of like, would you get full marks? The marking scheme always allows for a range of values. So long as you're close enough. Now, if I said the point of intersection was something like 616, I wouldn't get my marks then because I wouldn't have drawn this in any way accurately. Basically, it's just very slightly off the corner there. So I should have been a bit more careful, but I wouldn't lose marks for that. Okay, thank you.